Hello, and welcome to Cruising Through Calculus. My name is Alex, and today we're going to be walking through 4 related rate problems. So let's jump right in. Our first problem says, a jet is flying toward an airport at a constant altitude of 6 miles above the ground. If the distance z between the jet and the airport is decreasing at a rate of 400 miles per hour when z equals 10 miles, what is the horizontal speed of the jet? Okay, so to begin with this problem, we need to draw a picture. So let's say that we have an airplane, and the airplane is flying toward an airport. And let's just, for the moment, put the airport as a dot. Maybe like this. That's our airport. Now, if you read through the question, it says that the airplane is flying at a constant altitude of 6 miles. So that would be something like this. There's our altitude, always 6 miles above the ground. And then they tell us that the distance between the jet and the airport is decreasing. So the distance between the jet and the airport is going to be this line right here. And they're calling that z. And then finally, they want us to find the horizontal speed of the airplane. Well, why don't we kind of connect this here to create a little triangle, and let's call this distance here x. With our drawing now in place, we can actually answer the rest of this question. The next thing we want to do is write out the information that they gave us. For example, it says that the distance z between the jet and the airport is decreasing at a rate of 400 miles per hour. Well, that's this right here. And it said it's decreasing at a rate. So that means this is going to be a derivative. So the derivative of z, so the derivative of the distance between the airplane and the airport, is decreasing at a rate of 400 miles per hour. Because it's decreasing, we're going to make that negative. Okay, the next thing that they want is they want us to find the horizontal speed of the jet. Well, of course, the jet is traveling in this direction here, and I called this distance x. So if we find the rate of change of the distance, that's going to be the derivative of x, and that's what we want to find. And we want to find that when the distance between the airplane and the airport is 10 miles. Okay, good. We now have everything that the wording of this question gave to us. It's now time to come up with an equation based off of our drawing here. And I hope you can see we have a right triangle here, and we have all 3 sides labeled. So let's use the Pythagorean theorem. That's going to be x squared plus 6 squared equals z squared. Now, once you have this equation here, we're going to find the derivative of this equation. And we have to use implicit differentiation when we do this because we're finding the derivative with respect to t, and these variables here are not t, they're different than t. So when we find the derivative of x squared, for example, here's what we're going to get. We're going to get 2x, and then we have to multiply by the derivative of the inside, which is going to be dx dt. 6 squared is a constant. The derivative of a constant is 0, so I can ignore that. The derivative of z squared is going to be very similar to our 2x dx dt, except it's going to be with z's, like this. All right, now we wanted to find dx dt. So let's do this. Let's divide both sides by 2x. That way, we have what dx dt is equal to. Now the 2's will cancel here, and we'll get z over x times dz dt. This is good. It's now time to start plugging things in. For example, I know that dz dt is negative 400. I know that z is equal to 10. But hold on a second. I don't know what x is. So what we need to do is come back to our problem and see if we can figure out what x is. And indeed, we can figure it out because at the very beginning, we used the Pythagorean theorem and found the derivative of that. But we can use this to figure out exactly what x is equal to when z is 10. So let's plug 10 in for z and solve for x here. So let me write it over here. It's going to be x squared is equal to 10 squared minus 6 squared. So that's 100 minus 36. That's going to be 64. And then we have to find the square root of both sides. The square root of 64 is 8. So now I know that x is equal to 8 when z is equal to 10, and I can plug everything in down here. So let's do that. Z is 10. x is 8, and then dz dt is negative 400. Now 8 fits into 45 times, so 8 fits into 450 times, which means that we get 10 times negative 50, which is negative 500. And this is all measured in miles per hour here. Now, don't pat yourself on the back quite yet, because we're not done. If you look at the question, it specifically says, what is the speed of the jet? What we have here is the velocity of the jet, and I know that because it's negative. That means it's moving to the left based on how I drew this. So, in order to make it speed, all we need to do is just make it a positive 500. And that is our final answer. The next question says, a person who is 2 meters tall walks towards a light post at a rate of 0.5 meters per second. The light on the light post is 5 meters tall. How fast is the length of the person's shadow decreasing when the person is 3 meters from the light post? Okay, so let's start by drawing a picture. Let's just say this is the light post here. The light post is 5 meters tall. Let's say this is the person over here, and they're going to be walking toward the light post, and we know that they are 2 meters tall. Now, when the person is walking toward the light post, of course, is shining the light on the person, and it's casting a shadow. And that shadow has a certain length. And as the person gets closer to the lighthouse, the shadow is going to change. So, what we want to do here, to complete this drawing, is to think of the light rays as coming from the top of the light post down to the person, and then that's going to be casting the shadow here. And I hope you can see that when we do that, what we have constructed here is a triangle. In fact, this is a right triangle, even 2 right triangles here. Okay, so this is all well and good. Let's take a look at what the question asked us to find and write down all the information now. Actually, I just realized before we do that, I do need to label my drawing here. I did label the light post height and the height of the person, but I need to label the distance from the person to the light post. We'll call that x. And then the person's shadow, we'll call that y. And now we can start writing things out. Okay, so the question says that the person is walking toward the light post at a rate of 0.5 meters per second here. So if this is the distance here between the person and the light post, then that means that the rate that they're walking is going to be the derivative of x here. And because he's walking to the left toward the light post and this is decreasing, we're going to say this is negative 0.5 meters per second, like that. Okay, what else did they tell us? They want to know how fast is the length of the person's shadow decreasing. Well, the person's shadow is given by this y right here. This is the length of the shadow. So the rate at which the shadow is decreasing is going to be dy dt. Now we want to find that when the person is 3 meters from the light post. So in other words, when x is equal to 3. Like this. Okay, this is great. Now let's see if we can come up with some kind of an equation that makes all of this work here. Now as you look at this, you may be tempted to try the Pythagorean theorem because there are 2 sides of this triangle here. But actually, you should think of this as a set of similar triangles. We have the larger triangle with this side length 5, and then we have this smaller triangle with this side length of 2. So, because the smaller triangle is nested within the larger triangle, that means we have similar triangles, and we can set up a ratio between the 2. So let's just say this. You could set this up in any number of ways. Let's say that 5 is to, so this distance here, 5, is to this entire distance here. So that's going to be 5 is to x plus y, because we need the entire distance, is the same thing as 2 to y, like that. Okay, now let's take this and let's go ahead and cross multiply. We're going to get 5y is equal to, and I have to distribute the 2 here, 2x plus 2y. And then if I subtract the 2y to the other side, I get that 3y is equal to 2x here, like this. Okay, this is great. I now have an equation that's simplified from this. And if I find the derivative of this, I'm going to get dy dx's or dt's, and I'm going to get dx dt's, which is good because that's the information that we want to find, and that's also what they gave us. So let's go ahead and find the derivative. What we're going to get over here is 3 dy dt. And then over here, we're going to get 2 dx dt. Okay, so this is great because I know that dx dt is negative 0.5, so I can plug in negative 0.5 here. I'm trying to find dy dt, so the only thing I need to do is divide both sides by 3 and then plug in negative 0.5. So let's do that. We're going to get dy dt is equal to 2, I'm going to have to divide that by 3, times negative 0.5, which is really just negative 1/2. And the reason I write it that way is because you'll see this 2 should cancel with that 2, and we'll be left with negative 1/3. And then if you look back at the problem, we were working in meters and seconds. And so our final answer is negative 1/3 meters per second. That is the rate at which the length of the shadow is changing when x is equal to 3. This problem says an inverted cone has a diameter of 4 inches and has a height of 6 inches. Coffee is leaking out of the bottom at a rate of 2 inches cubed per second. How fast is the water level dropping when the height of the water is 3 inches? All right, let's start by drawing a picture here. So let's draw a cone like this, and let's label it. We know, for example, that the cone is 6 inches tall, and it tells us the diameter is 4 inches. Well, if the diameter is 4, that means that the radius here is 2. And then inside of this, we have some coffee here. And the coffee is leaking out of the bottom. So that means that the coffee is changing here. It's changing the height and it's changing the radius of the coffee as the coffee leaks out. So let's call the height of our coffee h because that's going to be changing. And then let's call the radius of our coffee r because that is also going to be changing. All right, this is good. Let's now write out all the information that they gave us. For example, what did they tell us? They told us that the coffee is leaking out of the bottom at a rate of 2 inches cubed per second. Okay, so what that tells me is that the volume of the coffee is changing. And it's changing at a rate of -2 because it's leaking out inches cubed per second. By the way, a key to figuring out that this was volume was looking at the units. It said inches cubed, so that made me immediately think volume. Okay, what else do they tell us here? They tell us that they want us to find how fast is the water level dropping. Well, okay, that's going to be the height. So that means we're going to find the derivative of the height here. And we're going to do that when what happens? When the height is equal to 3 inches. All right, this is looking really good. Let's go ahead and see if we can come up with an equation that uses all of this information here. And indeed there is. It's the volume of a cone. So the volume of a cone is pi r squared h over 3. Now that we have this, we're going to find the derivative of this. We have to be careful with this one because there are two variables over here that are being multiplied, r squared and h. That means we're going to be using the product rule. Okay, but let's start with this. The derivative of v is just dv dt. Now here's something that can make your life at least a little bit easier. Pi and divided by 3 are both constants. So let's take those, pull them out of our derivative, and once we find our derivative, all we need to do is figure out what is r squared times h. So the product rule. We need the derivative of r squared. Well, that's going to be 2r dr dt times the second piece, h, plus the derivative of the second piece, that's going to be dh dt, times the first piece, that's going to be r squared. And there we go, we found the derivative. All right, it's time to start plugging things in. dv dt is -2, that'll go here. dh dt is what we want. H is equal to 3, but wait a second. I don't know what r is, and I don't know what dr dt is. So whenever this happens, you got to go back and see if you can figure out what to do with your drawing and the information they gave you. Here's what we're going to do, and this is pretty clever, which is why this question probably comes up pretty often. We're going to take a cross section of this cone right through the middle, and we're going to look at half of that cross section. So let me show you what that looks like. The cross section is going to make it look flat, and then we're only going to look at half of it. So if I cut this kind of down the center like this, and then you also imagine me slicing through it like this is what we get over here. Now, let me label a couple things. We know that the cone is still 6 inches, and remember the radius is 2. And in here is our coffee. So let's do it like this. Now the coffee has a certain height h, and it has a certain radius r, just like what I labeled over here. Now this is actually just like the last problem. This is going to be two similar triangles because they're nested inside of each other. So we can set up a ratio here. Let's do it like this. Let's say 2 is to 6 as r is to h. And then let's cross multiply. I'm also going to simplify. 2 over 6 is really just 1/3 here. So it's going to be 1 times h, which is h, and then 3 times r. Okay, well this is actually really good because I want to know what is the radius when the height is 3 inches. So I can plug 3 in for h here. 3 equals 3r. Well, hey, that's going to be pretty easy to solve. That means r is equal to 1. So now I know what r is when I plug it in down here. Okay, but what about the dr dt? Well, I do have a new formula here. Why don't I find the derivative of this formula, and let's see what we get here. dh dt is equal to 3 dr dt. Okay, this is good, because if I divide both sides by 3, I know what dr dt is. dr dt is going to be dh dt divided by 3, or if you prefer, 1/3 times dh dt, like this. This is perfect because now I can take all the information that I figured out and plug it in here. So let's do that. Let's plug it all in. Okay, we've got a pi over 3 on the outside. We have 2 times the radius, that's 2 times 1. Then we have times dr dt. Well, that's 1/3 dh dt. Times the height, which we know is 3. Plus, oh boy, dh dt, that's going to stay the same, times r squared. Kind of running out of room here. All right, so here, let me do this. Let me take this answer that we just wrote down here. Let me erase some of this and move it up here, and then we'll keep going. All right, so I took the answer that we got, I put it up here. I also set it equal to -2 because -2 is what the volume is doing. It's decreasing at a rate of 2 inches cubed per second. Now let's see if we can figure out all of this here. So let's take a look here. I do see a 1/3 times a 3. That means that these two will go away, and we'll be left with a 2 dh dt. Over here, 1 squared is just 1, so we're going to get plus dh dt. Now, if I multiply by the reciprocal, I can multiply this side by 3 over pi. That'll get rid of this 3 over pi when I multiply this side by 3 over pi as well. And then I'm going to get -6 over pi is equal to 2 dh dt plus dh dt, which is 3 dh dt. And then I can divide both sides by 3, and I'll be left with my final answer. Now let's see here, the units that we were working in were inches and seconds here. So this is going to be in inches per second, and that is our answer. This problem says, a ladder 10 feet long is leaning against a vertical wall with the other end on the ground. The top of the ladder is sliding down the wall. When the top of the ladder is 6 feet from the ground, it is sliding down at 2 feet per second. How fast is the bottom moving away from the wall at that instant? Okay, so let's start by drawing a picture. Let's say that this is our home over here, and then we have a ladder which is sliding down the home, and we know that the ladder is 10 feet long here. Okay, let's label a couple of other things. Let's say that the height from the top of the ladder to the ground is y, and then the distance from the base of the home to the bottom of the ladder is x, like that. Now it's time to start writing out everything we know. For instance, the problem tells us that the rate, let's see here, it says the ladder is sliding down at 2 feet per second. So that means this distance here is decreasing because it's going down, or in other words, dy dt is -2 feet per second. Now, they want us to figure out how fast is the bottom moving away from the wall. Well, that's going to be dx dt. And we want to know what is that rate when the distance from the top of the ladder to the ground is 6. So in other words, when y is equal to 6. All right, this is great. Now, let's see if we can come up with an equation that matches this here. This is a right triangle I've constructed, so let's use the Pythagorean theorem. X squared plus y squared equals 10 squared. This is going to be perfect because when I find the derivative of this, I'm going to get dy dt's and dx dt's that pop out of it. So let's find the derivative of both sides here. We're going to get 2x dx dt plus 2y dy dt is equal to, and the derivative of a constant is always 0. Okay, now they wanted us to find dx dt, so why don't we solve for dx dt? Let me subtract the 2y dy dt to the other side, and then let me divide both sides by 2x. When I divide by 2x here, that will cancel with this 2 over here, and we'll be left with this, negative y over x dy dt. Okay, it's time to start plugging things in. I know that y is equal to 6. I know dy dt is negative 2. Ooh, I don't know what x is, at least not yet. But I can figure it out, because if you look right here, I have an equation where x squared plus y squared is equal to 10 squared, and if I plug 6 in for y, I can find out what x is. So let's do that. We're going to get x squared equals 10 squared minus 6 squared. So that's going to be 100 minus 36, which is 64, and the square root of 64 is 8. So that means x is equal to 8. We now have everything we need, and we can plug it in here. dx dt is going to be negative y, so negative 6, over x, which we just figured out is 8, times negative 2. Okay, well, we have a negative times a negative, so that'll give us a positive. That means we'll get a 4 here, and then 6 over 4 is 3 over 2, positive. So it's going to be 3 over 2, and then feet per second here. Feet per second is going to be our final answer because we're measuring things in feet and second, and that is the rate at which the bottom of the ladder is moving away from the wall when y is equal to 6. Now that I've walked through these problems with you, I want you to look back and think about how we approached these problems. The very first thing we did was draw a picture and label it. Drawing a picture and labeling it is extremely important because the letters that you decide to use when you're labeling it are the letters that you're going to use when you're using a derivative, and the picture that you draw will help you find the equation that you need. Usually it has to do with triangles, but not always. Once you do have your picture drawn, you can then go back to the problem and write out everything that they gave you and then everything they want you to find. Remember, anytime they mention a rate, that's always going to be a derivative. Finally, once you have your main equation based on your drawing and the information they give you, find the derivative and start plugging things back in. Sometimes you'll see that you don't have every single piece of information quite yet. So that means you have to go back to the beginning and see if you can find out the missing pieces. Once you do find those missing pieces, you can plug everything in and solve for what they want you to solve. It's quite a process, actually, and it takes a lot of practice to get good at these. If you found this video helpful, you might consider checking out my website, which is linked in the description below. You'll be brought to Infinity Learning Academy, where you can find Cruising Through Calculus. At Cruising Through Calculus, we have over 100 videos and documents to help you get through your calculus class, including videos for each topic, practice problems, and full video solutions for those practice problems. I hope to see you there, and together we can cruise through calculus.